Work and power and how they're related to energy. The work-energy theorem is the bridge that relates forces and energy. Remember, the change in energy is equal to work being done. So if you're changing types of energy, changing amounts of energy, there's work being done. And that equation is FD cosine theta, where theta is the angle between F and D. And just remember that cosine of 0 equals 1, so if they're both parallel, you have the maximum amount of work. If you have a varying force, then we're going to use the integral of FdR. Or if we have an F and D graph, then we know the area under the curve is going to equal our work, or equal to our change in energy. Maybe our change in kinetic energy, and from that we can figure out the final velocity. Work is scalar, but can be positive. If it's positive, then we're adding energy to the system. If it's negative, we're removing energy. Or there's just zero work. If cosine 90 is what we're working with between F and D, then there's zero work being done. Power is the rate that work is done or energy is converted from one form to another. There's several equations that are going to be useful. Change in energy over time, which is the same as work over time, and work is FD cosine theta over time. And D over T is velocity. So we get force times velocity cosine theta, where again, theta is the angle between force and velocity in this case. Or if we have things that are changing, we use the math of change. P equals delta E over delta T. dE is going to be our differential change in energy. Therefore, we're integrating FdR, which is the same as our change in energy, which equals our work. And we can plug that into our power equation.